All right, so here is your 2017 Semester 2 final review. A couple of things that you need to know. First off, this is going to cover everything that we did second semester. Okay, we're going to take, I broke the 15 questions up into two different parts. So we'll take one part on Monday and we'll take the other part on Tuesday. Then we won't be pressed for time in any way. Okay. You are allowed one note sheet for the final. I gave you, after the test yesterday, I gave you back your first semester final ones. And so you can fill out the blank side on that. If you weren't in class yesterday, then Mr. Moen has them for you and will hand them out to you today in class. If you didn't make one for first semester, but I think all of you made at least something for first semester, you don't get to use one for second semester. So the ones that I handed back to you are the ones that you have to use. You got to fill in the back side of them. You can't make a new one. You can't just make it on one side of another sheet. You get that one sheet that I handed back to you. That's what you get to use. Okay? So the final is going to be 15 questions long. It's 5 pages. And I broke it up into, so on Monday you'll take 3 pages, and on Tuesday you'll take 2 pages. Each question is worth 2 points. There's 1 multiple choice question, 3 graphing questions. The rest are short answers, show your work. NTC tells me how I can grade this final, and I have to grade it on a 2-point scale, and so I can either give you 2 points, 1 point, or no points. That's it. I can't give half points for anything. It's either all, half, or nothing. Okay? And it will go into that 20% of your final grade for the class. Okay? We did 3 chapters in second semester. I know it seems that we should have done more, but we only did 3 chapters. We started out in chapter 3. Chapter 3 was all about solving systems of equations, finding equations, etc., like that. Okay? So that's chapter 3. Okay? Then we went, actually, and this was in chapter 3 also, put that in chapter 3. So chapter 3 is a pretty big one. Okay? Then we went on to sequences and series, which was chapter 12. And then we went on to conics, which was chapter 9. Okay? So here are some different topics. Topic number 1 is solving a system of equations. That's from chapter 3. We have multiple ways to solve a system of equations. First off, we could graph it. Second, we could use substitution. Third, we could eliminate. We could use Cramer's rule. Or we could use matrices. Now, you're going to have on your final, I will tell you that you will have some 2x2s. You'll have some 3x3s. Okay? So it kind of is your choice as to how you want to do them. Okay? If this were me and I was doing question number 1 and it was on a final, the first thing that I would do is I would reorganize my second equation, and then I would rewrite my top equation after I multiplied it by 2. So then that gives me 8x plus 14y equals 20, because that set up elimination for me. When I add x is 3, I'm going to put that back into either one of the two equations. I'm going to pick the top one. 4 times 3 is 12. Plus 7y equals 10. Subtracting 12 from both sides, 7y equals negative 2. So y has to be negative 2/7. If y is negative 2/7, then, and x is 3, if I plug it back into my original equations, I get 12 on the top for 4x. I get negative 2 for 7y, so 12 plus negative 2 is 10, so it checks out in my first equation. In my second equation, negative 3x is negative 9. 14 times negative 2/7 is negative 4. Negative 4 minus 5 is also negative 9. So my answer here is the point 3, comma, negative 2/7. In a 3x3, I have to pick either the first equation, the second equation, second and third, or first and third, and I have to eliminate a variable twice. Right? And then I can use substitution or elimination or Kramer or whatever. Okay? So I would probably go first off, I would go top equation plus bottom equation. Top equation plus bottom equation gives me 3x plus 3y. The z's cancel each other out, equals 0. Okay. And then I would go the top equation times 2 plus the middle equation. So then that would give me 8x plus 4y minus 2z equals 2. And then that's going to be added to x minus 3y plus 2z equals 14. So that is going to be 9x plus y equals 16. Multiply my top blue equation by negative 3, that would give me negative 9x minus 9y equals 0. Add those two together, gives me negative 8y equals 16. So y is negative 2. If y is negative 2, then 3x minus 6 equals 0 if I plug it into that equation, the blue equation right there. So 3x equals 6, so x is equal to 2. If x is 2 and y is negative 2, I'm going to plug it back into my third equation down here. So then I get negative 2 minus 2 plus z equals negative 1. So that's going to be z here is positive 3. Okay. Now, if I don't want to do all of that, I could set up a matrix equation with all of my coefficients times x, y, and z equals my numbers, and then multiply by the inverse matrix, which I did right there, and we got x is 2, y is negative 2, and z is 3. Okay. So that worked out well for us. So then my final answer here would be 2, comma, negative 2, comma, 3. Solving this system of equations, this is a quadratic system. There will be one of those on the final two. So first off, we got a line and a circle. So I would take this bottom equation and I would solve it for y. In this case, we're solving it for y or x, doesn't really matter. And then I would substitute into the circle equation plus, now that's going to become x because that's my y, equals 32. So x squared plus x squared is 2x squared equals 32. X squared equals 16. So x is going to equal plus or minus 4. Then now I've got to check positive 4 in the first equation. So that would be 16 plus y squared equals 32. So that's going to be y squared equals 16. So y is going to be plus or minus 4. When I go into the second equation, negative 4 plus y equals 0. So then y would have to be 4. So that makes the only point there being 4, comma 4. Then I check negative 4. Negative 4 is going to give me the same for y. So y is going to be plus or minus 4. But negative 4, when I put it into my second equation, is going to become negative of negative 4 is positive 4. Plus y equals 0. So y here is going to be negative 4. So that also gives me the point negative 4, comma negative 4. So that line intersects that circle in those two spots. Then we went on to chapter 12. Chapter 12 was all about sequences and series. There are two kinds of sequences and series. Arithmetic. In an arithmetic sequence or series, we add to get the next term. In a geometric series, we multiply to get the next term. Okay? There is a world of formulas from this chapter. Okay? So this first layer of formulas right in here are the basic any term kind of formulas that we could use to find any term in the sequence or series. Okay? And then down here on the second layer is all of our sum formulas. Okay? Remember, though, that this particular one is only used for infinite geometric series. Okay? So we got that. For both, find the eighth term and the sum of the first 8 terms. Well, the first thing that you got to do is you got to look at it. Okay? And so here I'm looking at this one, and I'm going to say, well, this one I'm either going to multiply by negative 1/4, which then that doesn't work on the next one, because the next term then would be negative 1/4. So I'm not multiplying here. Okay? So then I got to look and I got to see, all right, here I'm adding 5. Well, here I'm adding 5. Well, here I'm adding 5. Seems to be the pattern there that I'm always adding 5. Because I'm adding, this is arithmetic. So my arithmetic series is a sub n is equal to a sub 1 plus d times n minus 1. Got that from right there. Okay. So my first term is negative 4. I'm looking for my 8th term. My constant difference, or my difference, is 5. I'm looking for the 8th term. 8 minus 1 is 7. 7 times 5 is 35. Negative 4 plus 35 is 31. So the 8th term is 31. Now, to find the sum of the first 8 terms, here, now what we would do is we would need the number of terms, so there's 8 of them. We're going to divide that by 2. I'm going to take the first term, I'm going to add it to the last term, which in this case is the 8th term. Negative 4 plus 31 is 27. 8 divided by 2 is 4. So the sum here of the first 8 terms is 4 times 27, which is 108. Looking then at the next one, once again, it doesn't appear to be arithmetic because I would have to add 16, and here I didn't add 16, I actually added 80, so that's not going to work out, so it is not arithmetic. However, I did multiply by 5, and I did multiply by 5, and I did multiply by 5, okay? So that to me says that it is geometric. So now I'm going to look in this geometric column here for all of them. So my geometric formula is G sub n is equal to G sub 1 times r to the n minus 1 power. So I am looking for G sub 8. That's going to be 4 times 5 to the 8 minus 1 power. So that is 4 times 5 to the 7th. Well, 5 raised to the 7th power is 78, 125. And then that times 4 is 312,500. So my 8th term is 312,500. Then I need to find the sum of those 8 terms. So the sum formula for geometric sequences or geometric series is going to be the first term, which was 4, times 1 minus my r value to the n power divided by 1 minus my r value. Well, I can either type that in the calculator as is, or I can figure out what those numbers all are. Either way, I get 4 times the quantity of 1 minus, whoop, tap the brakes, missed it, of 1 minus 5 to the 8th power, all over 1 minus 5. And I get 390,624. So there's that. Now, one of the questions might be, list the first 4 terms of the following sequence. Okay? And then you might see this goofy exclamation point right there. What that stands for is factorial. So a little sidebar action, 4 factorial is going to be 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. You take the number and you multiply it by every integer less than it until you get to 1. Okay? So 4 factorial is going to be 24. 7 factorial is 24 times 5, which is, or here, let me just do it on a calculator so we can go 7 times, tap the brakes, where do we go? We can go 7 times 6 times 5 times 4 times 3 times 2 times 1 and get 5,040. Okay? Now, okay? So if it says list out the first 4 terms, that's going to be when n is 1, because that's what it says we need to start with. N is 2, n is 3, and n is 4. So if n is 1, then this becomes negative 2 to the first power divided by 1 plus 1 factorial. Well, negative 2 to the first power is negative 2. 1 plus 1 is 2, and 2 factorial is also 2. Okay? So this becomes negative 2 over 2, which is negative 1. When n is 2, then this one would become negative 2 squared all over 2 plus 1 factorial. So that is 4 divided by 3 times 2 times 1, because 2 plus 1 here is 3. Okay? So 3 times 2 times 1 is 6. So this becomes 4/6, which reduces to 2/3. When n is 3, this would become negative 2 cubed, which is negative 8, all over 3 plus 1 factorial, which is 4 factorial, which is 4 times 3 times 2 times 1, which is negative 8 over 24, which is negative 1/3 when you reduce it all the way down. And lastly, we'd have 4, where n is 4, so we'd have negative 2 to the 4th power, which is positive 16, all over 4 plus 1 factorial, which is 5 times 4 times 3 times 2 times 1, which is 16 over 120. Both can be divided by 8. Actually, both can be divided by 16. No, both can be divided by 8. So that would be 2 over 15 there. Okay? So the first 4 terms in my sequence are negative 1, 2/3, negative 1/3, and 2/15. Hint, hint, there might be a factorial on the test. Okay? 2 topics that I didn't cover: matrices and how to work matrices. That comes out of, you can find all that information in your textbook. And conics. We just did 7 weeks worth of conics, so you should, we actually almost did 2 full months of them, because we did all of April and we did all of 4th quarter basically as Ben conics. So, yeah. So let's just say, instead of a month, let's say 4th quarter. So that's your final. Okay? Study well. I'll be in. Email, text, send me a letter in the mail, however you want. Okay? Study well for your final. Have a great weekend.